Good afternoon, everybody. I'm Sajeev Mayandi. I'm the Senior Director at Sleep Number, taking care of architecture and data platform.
And I'm Alex Rivlin. I am Director of Data Platform at Sleep Number.
So today we'll go over our journey of implementing Unity Catalog and delta sharing in a use case that we used in Sleep Number, that is data sharing. So we shared the data, and then as a part of implementation, we use Unity Catalog and delta sharing. So we'll go over that. So a little bit of agenda. So we'll go over on Sleep Number, then some of the data architecture related to Sleep Number ecosystem, that is IoT part, and we go over the data sharing use case, some solution architecture related to that, and then Alex will then run through the implementation, migrations, and the lessons learned as a part of that. So when you hear Sleep Number, most of us might be thinking, hey, this is a bedding company, and what are they doing out here in Databricks conference? Well, yes, we do sell bed, but we do sell smart bed. And we are a wellness technology company. Our bed is equipped with a very high-tech technology. It helps in controlling the temperature of the bed. It controls the firmness of the bed. It also helps in articulating the bed up and down. So that is the bed operations. But we do also track the sleep information of 2.5 and up million customers. And the data for the sleep information come into our data platform. So we have billions of hours of sleep data in our data platform. That tells the story why we are here in Databricks conference. So a little bit of our architecture. So to give you a context here, our architecture is a little bit more complex than what you see out here, but I'm tailored it to this particular session. So let's go over first on to this bed. I mean, that's our bread and butter. But if you see, this is our smart bed, and we have a pump that gets clamped beneath it. And in that pump, we have an NXP chip, which is having a compressed version of a Linux operating system. That's what you could consider it. And it is connected to various sensors, like pressure sensor, temperature sensors, and then articulation. For articulation, we have a bunch of other sensors. But the point here is, these sensors are used to control the temperature of the bed. That is, the temperature sensor is to control the temperature of the bed. And then pressure sensor is to control the firmness of the bed. Then actuators are used for articulation of the bed, that it can go up and down. And then if you see, the app here is connected to the bed through a Bluetooth and API. So we use app pretty much like a remote. We do also have a remote, but we use the app as a remote wherein we use that to do a bed operation. That means you want to articulate a bed, you want to articulate your partner's bed, control the temperature of each of those beds that you see, and then control the firmness. So that is about the bed operation. But the data part comes from the sleep information. That means our customers sleep on this bed. So when they sleep on the bed, the data from the pressure sensors come in. It's in an analog form. We convert it into a digital form. And then what we do is we have AI algorithms which are running on an edge. And those algorithms basically give biometric information about the customer. That means we calculate the respiratory rate, heart rate, and whether you're moving left, right, based on actuators and others. So just imagine a person sleeping here 8 hours a day, and every night this set of data for every n second goes into our data platform. So that's where you see this streaming line out there. And eventually it goes into the data platform. So that's where we have billions of hours of sleep data for our 2.5 plus customers. Now, we do have a lot of other applications which are built on the data platform. But in specific to this session, I've just zeroed in on a use case called data sharing. That means we collect the sleep data and we share that data for research purpose. So you see here, a line that goes from a data platform onto the research partner. So the idea here is to export the data set that we have in terms of sleep to research partners who are interested in doing sleep research. And then another use case specific to data sharing is we basically do a cross-cloud communication. We put those data into an Azure platform, and then we have built an analytics on it. That's more of a use case. But the idea here in this particular session is that for this particular use case, how did we use Unity Catalog? How did we use delta sharing? And that's where we go into the weeds, and that's where Alex will get in. But for now, let's go a little bit on an architecture on the data sharing, and then the rest. So again, the use case we are talking about the data sharing, and there are two categories there. One is a data download, and then one is data sharing platform as a service. So data download is in a case where researchers say that, hey, I want the data set in my vicinity. That means in my compute environment. So for them, we basically collect a data set, send a URL, they go get the data set, do their work. That's one kind of researchers. Then there is another kind of researchers wherein they log in into our system. When I say they log in into our system, that means the Databricks system. And then we prepare data sets for them, and then they do research for a contract period that they have, finish it up, and then move on. So these are the two categories, and obviously we have an internal use case where I already mentioned how we communicate that. So a little bit on the data download solution architecture. So we use Jira for traceability and onboarding. And then as a customer comes in, hey, they want a data download with, say, X data set with X age and stuff like that. So we prepare that, we provide that through, and then for Jira, we use traceability. And then we use Jenkins as an orchestrator. So if you see, Jenkins, the first job it does is prepare the data sets that we have, because we can't give PII and other information, so it needs to be anonymized. So all those is done as a part of a data preparation in the Databricks. And then we put that into an S3 bucket and clamp an CloudFront URL in front of them, and then send them an email and with an expiration and others, and they click it, and voila, the data is there in the data set. Simple, isn't it? So this is one-time use case, and researchers, I would say substantial amount of researchers out here in US want this, because the data set needs to be in their environment in order for their research to be approved, because researchers get an approval based on certain criteria, security criteria. So for them, this works perfectly fine. So now conversely, let's take a platform, data sharing platform as a service. In this case, we have to actually provision a cluster. We have to provision a data set. And then obviously we'll still use Jira and communications and orchestration as a part of it. But this is based on a contract. That means some researchers or some companies comes in and say that, hey, I want to research for 6 months or 1 year. So that is a contract period. We provide the data sets they're interested in this platform that is built in our place. And then they log in, they do research, use the Databricks tool as a part of it, and then they move on. But at the same time, when they move on, we have to deprovision it. So platform as a service consists of provisioning as well as deprovisioning. So a little bit on the solution part of it is, again, we still use Jira here. We use Jenkins as an orchestrator. But here, Jenkins, the first step it does is it's provision the cluster. And that's where we use Terraforms, right? And then we have to prepare data set that is used by that researcher or researchers, right? And that's why we use Unity Catalog. We have them register into our system. We send them instructions to basically log in, and voila, now they are into our system in this form. So if you see on the left side is our data platform. On the right side is a data sharing platform, and each partner gets its own Databricks workspace, right? Each workspace have a conditional access. If we have multiple users, each user will have its own access-based permissions for the data set that they are allowed to see and do analytics. They could use Spark, they could use SQL endpoint, and the most important thing is they are separated, right? So each partner will get it's anonymized data. What they are interested in specifically is the sleep information about a category of users, and that's what they are going to use once they get this. Now, one thing important to note here is the researchers are typically using this data set as a data analysis tool. They build models like algorithms and others, and for that, this compute. That's why we provide this compute information as a part of the workspace, database workspace to them. And another important thing here is, again, they will use delta sharing as a part of this whole solution and the Unity catalog. And that's where Alex will go very deep into on what lessons we learned. So as a part of a solution, not as a part of an implementation to be specific, what we learned was initially we thought, hey, we will just build a platform and let people come into our system and do research. But what we realized, specifically in the US, many of the researchers have very tight security requirement and would require data sets to be there in their environment. And that's why we learned that, hey, the platform as a service may not work here. It will work well in Europe environment, because that's where there are fundings and other things available for platform as a service kind of a model. But here, people do want data in their data set. So substantial amount of researchers would be use that offering. The other thing that as we went into that journey of data download option, we realized that, hey, why don't we use DBFS API, like Databricks given API? But what we realized when we started using that is it requires the customer to log in again back. That violated some of our UX requirements, like we do want our researchers to do a one-click download. So that means you get a URL, you click it, and voila, you have a data set. So that was one thing that we realized, and hence we did not use DBFS API. We ended up using or building our own kind of a custom solution with, of course, some bells and whistles and tools from Databricks. So with that in mind, the solution part, architecture part, and the business part is done. So I will now hand it over to my friend Alex to move on to the next.
Right. So we talked about lessons learned, and I want to point to this Databricks API. The things I will be sharing is related to us using Databricks APIs and CLIs. And we'll talk about maybe less expected aspect of migrating to Unity catalog and delta sharing. And you will see it in a moment. So let's go to the next. In slide that Sajeev started with here, you saw two clouds. The AWS cloud and Azure cloud. And Sajeev was talking about research partner. But the very first and very dear partner to us is this Databricks Azure team that is our own team that has to go through the same exact journey as the external research, because the Databricks in Azure is just as foreign to us, starting from Databricks and AWS as another research organization. So our first journey was to get Unity catalog in AWS, and then, given what that enables, pilot the whole process of sharing data with our own team in operating in Azure, and see that all connections are working and all the lessons learned are completed. And that enabled us to then later scale and be confident that when real customer will come, then there will be no surprise. So let's get back and start looking at the history of how we approached that project. Our first implementation was in Azure, in AWS. At Sleep Number, AWS is much younger project. It's only a few years old, and it started as a greenfield. So whoever worked on it 4 years ago had luxury to come to blank slate, build things properly with the frameworks, with the right design where things are reusable and modular, and there is includes and shared metastore kind of JSON files. So that migration was not really eventful, to be honest. We started, I'm not going to read the slide, you can see it, But we started with POC. POC went very well. Everybody can follow instructions. There's so much documentation. You can create a workspace. You can create meta store. You can create table, attach it to the meta store. It will be Unity catalog managed. So POC goes extremely well. Next step was to migrate a development workspace. It's a very small workspace. I'll share a secret. Our teams are really small, low single-digit people-sized teams. Development workspace gave us some surprises. UCX utility was crashing, was not giving right output. And we saw that migrating production will become different from doing the POC. We reached to our friends from Databricks and got a senior architect to be with us for a few weeks. And that was, speaking of lessons learned, that was very impactful lesson learned. In the choice of do we give SOW to Databricks or another consulting company, listing 10 workflows, 20 tables, 10 notebooks, please migrate, versus invite somebody who understand in depth the nuances and can teach our team, we selected the second choice. And what we learned may not apply today as much because UCX utility has many, many revisions, and the things that we saw would not maybe necessarily be there now. But the person who had many implementations came with a clear implementation plan and kind of configurations and settings done right first time. So this is the lesson we learned in AWS. It took us approximately a month to migrate first set of few tables, and then pipeline goes on and on. So at this point, what did we have? We had the Unity catalog in AWS. We had tables migrated to Unity catalog in AWS. We had workflows that could use those tables. Now let's go to the Azure side. Azure is a little bit different than AWS. I've said that AWS is clean slate, it's designed with a framework, there is medallion architecture, they include files. Azure probably also was clean slate 10 years ago with 5 generations or more of developers that some of them even never met each other and different teams. So it was a collection of many things. And the first thing we saw there is that in Azure, you have a tenant. So Sleep Number is a tenant. And we have subscriptions. Subscriptions A and B. In our case, it is a lower subscription and production. And if you have a Databricks workspace in a subscription, it is tied to that subscription. In another subscription, will be tied to production subscription. As a Databricks objects like views and tables, there is no visibility across subscriptions because they're managed by different Hive meta stores and there is just no visibility. What is the solution? Obviously, when you have Databricks with different workspaces, you would come to projects that require to exchange the data. And the solution, as you see, generation 1 was, well, unfortunately, let's get access to the blob store. Both Databricks workspaces can mount the blob store and use it, and it works. But it makes people like me really uncomfortable because now we have rather random access to blob store that might have important data. So we went to the next step and we created ETL jobs where now we have 2 blob stores and a very intelligent job to copy from here to here. So we don't have to grant as much access anymore, which is good. And it's really good for our friends from Databricks because now we have a job that consumes DBUs and runs every day, and if it stops, we have a problem, right? So that's not really great idea. So when we went to Unity Catalog enables visibility across subscriptions and Databricks workspaces. Workspaces you could see in subscription, but not across. And now, wonderful thing, you can see tables in that meta store. If they are in Databricks in Azure, there is one meta store per region. So our implementation happened to be in US West. So we created meta store in US West region. We enabled this 2 Databricks workspaces to access that meta store. And now we can see tables from one workspace in another workspace. That is very big. I cannot express enough how big deal is it for our maturity and clarity and the removal of unnecessary noise of some job failed, and for our stability of our product. Now, but enabling MetaStore is only step one. And there are many videos and there is documentation that you can follow to do the same thing as we did. You enable MetaStore, you create table, set it as Unity Catalog managed table, everything will work. What I want to focus here is a little bit different. First, I want to talk about our specific case of security approach that was found in Azure. In AWS, we have infra team that has necessary access, and when we talked about creating Unity catalog, configuring things like Delta Share, I didn't even want to talk about it. I said that wasn't an issue. They did it. It was not an issue. It happened that in Azure Databricks, a lot of things are really welded deeply in Azure. And in this case, in Sleep Number specifically, permissions to create a MetaStore require Databricks account access permission. And that permission was given to a global admin, site admin IAM role. So now, in order to create MetaStore for our POC, which is not eventful at all, we need to engage with the corporate security team and explain to them what we want to do and why we're bothering people who has nonetheless access that entire Azure configuration access. So all of a sudden, our approval cycle, our requirements for documents for ARB became extremely interesting. In our case, it took extra months to get through that. In retrospect, I think it's good because that scrutiny forces us to write more things, and those things should be written. But just sharing, confessing here in big room that we found it after the fact. So ideally, we would have found it before and put it in our project plan. Okay, let's move now from this subject to the next. And oops, I skipped through the plan. Yeah, so some of you also operate Databricks, right? So what is a typical team size for users, for business analysts, for people who write SQL? Like how many people have teams like less than 10 people that, okay, so few people have small teams. Now how many people have teams less than 20 people writing different SQL? All right, you have few. Okay, so that is interesting room. So either people have very large teams and I'm jealous of you, or you're not telling me the story. Anyway, so say you have between 10 and 20 people writing the code. Let's assume they've been doing it for a few years. How many notebooks do you think you find? Like, give me guesses. I need 3 guesses. My SAP friends, give me a number, please. In SAP, how many reports you find if you have a team of 10 people writing HANA reports? All right. Okay, so I'll skip through the suspense. We found over 4,000 notebooks that now are there. And when we, at this point, we created the POC. Of course, we made the table. Now we have a table, and now we're ready to go from a PIC table 1 with 2 fields, date and quantity, to actual data. And you do it, it triggers a change where table is now no longer referenced with 2 layers of hierarchy, where you have a schema followed by table name. And now that becomes 3 layers of hierarchy. You need to have a catalog, a schema, and a table name. That means that in your SQL, you need to prefix your table with a catalog. It's a really trivial procedure. But if you change your source code, you need to deal with it. You have a new code revision, somebody has to test. If there is important report, maybe there's some compliance requirements and all that. So you cannot just go and change. And moreover, you cannot just make change in the backend and have all the notebooks just die. So then we have this question for our users. I say, Sajeev, would you just, I have project manager, TPM, and they want me to do it next sprint. And you've been around, can you change table like products? And can you change all the notebooks that have table products and just prefix it with a catalog? That will not be a good choice, and our users would not like it. But the bigger problem is, and this is what I think, if you write down one thing from this, it's not that users wouldn't like it, is that even users tell you the answer, that's not a true answer because they don't have knowledge of each of the 4,096, if I remember right, notebooks, and each of the includes and the dependencies between those notebooks. They may tell you something, but it is not true. How will you find true answer? You will find true answer after about a year, because when all of your infrequently running jobs will start failing 6 months after you change to Unity catalog, then you live through that cycle and then you find it out. And this is what I wanted to center now is we did different approach. We used Databricks CLI and API to do it programmatically. And what we did is we expanded the scope first, and we found all the code that uses Databricks, one workspace at a time. We don't have that many workspaces, so you can do one workspace, two workspaces, every workspace. You expand all the code, then you classify it and contract into the code you need to worry. And you worry about this code at a different level. Some things really has to go through scrutiny, something goes through quick change. But at the end, you can show a report and that tells you that you did not forget that one temporary notebook that actually is included in some really key report. Anyways, so we use two approaches to get. So first we need to get a source code. What source code do we need to get? Each and every line of a code that is there. In our case, it was done in two places. Workspace has notebooks, and I'll show you exactly how we get the notebooks out of Workspace. And then there is also notebooks in the Git, for which it's really like one-liner, git clone repo, and you have it. After we collected all the source code in one Linux directory, we can now search it through it. Simple tools like even grep will tell you with the right, if you want to use Python, you can write Python, but you can easily find each object, each notebook that refers a table you're trying to upgrade now. If you do that, you can easily then use programmatic code editor, sed or Python, and programmatically stick the catalog in front of the table name without spelling errors, without typos, without omissions, and do it right. After that, you can create unit tests, because you can run the notebook as it was and the notebook as it is proposed, compare the results, and have some data quality metrics. But there is a trick, and so we put a break here. If you did that, you could run a notebook that I wrote right when we started the project 10 years ago that says drop table users and then create table users with these new fields. And if I run it against production, because my role is powerful, it's going to have bad results. So we further classified all the notebooks as create, update, and delete to be treated differently than just reports that select data. All right, so let's take a look in details how we did it. We used Databricks APIs that I love. There is a link in documentation that shows APIs provided by Databricks. They give you access, trivial access to everything you see in Databricks screen. You want workflow, it's there. You want Genie, it's there. You want notebooks, it's all there. The link before Databricks API brings you there, or you just search and there is one page. And all of those programs work really similar to what you will see in this screen and the next. These are REST APIs. Not going to impress you by saying that I have authentication here. And there are some predefined URLs that you need to set, and we will be using them in the next function that I'll show you. So with this simple setup, we can now access objects and recur through them to find what we want. So in the next slide, we're going to do exactly this. Right here where the captions are, is a first call to the function called list notebooks, and it gives you root directory. So before we actually get here, you probably think, Alex, why are you making such a fuss? You go to Workspace UI and you search, and it will give you all the workbooks with this table. Yes, indeed it will, but you get multiple pages in the output, and you will not be able to like replace and test and manage things. So what I was trying to do here, search is great, It's absolutely necessary, it's wonderful. But what I was trying to do here is to get hand on the source code so I can analyze it, including dependencies, because search will not search dependencies. If I have run directive, run some functions dot setup dot something, which uses table I'm trying to change now, that search will not catch that because it looks at one notebook at a time. So back to here. Very simple code work through. List function takes set up parameters and get a list of objects. It returns you array. These are all the objects. We're only interested in two types of objects: notebook, directory. If it's notebook, we do something with the notebook. If it's directory, great. We call ourselves again with a little longer path. Okay. What happens if it's a notebook? We call another API. All these APIs are listed. This development is maybe one-day development, but the power it gives you is pretty good. You call another API. You provide these parameters here. So you're asking for download, you're asking format for the source, and added the path to the specific notebook that we found in this directory. And with base64 decoding UTF-8, write to the file. Now we have it. Okay? Great. So now we have this one big directory, has a lot of text files, they're notebooks. What to do with them? Then we go to Excel, because we can't complete any one project without going to Excel. And it really helps us to classify and to have very specific conversations with the people we need to talk to. On the right side, you see a list of the notebooks. On the left side, things we care. Does this contain drop, but it also contains update, delete as well, right? Insert also. Don't want to insert in production something, right? Very simple regex searches will tell me that. If I have table and I go recur back and I say update, delete, drop, very simple, I'll find it out. Programmatically for 4,000 notebooks reliably. Contains import, same thing. If notebook has run directive, if it's there, then you have it. Contains tables, that's important one. If it doesn't contain my table, we filter this out. And now, after looking at the first three tables, I have a short list of notebooks they can discuss with people like Sajeev because they wrote them. And it makes our conversation focused and simple. And we are not asking questions that we know do not have answer at all. So that helped us to migrate tables to Unity catalog, enable 3-layer hierarchy, and not trouble our workflows, not expect our failures. So let's find where we are now at this point. Now we can remove blob access and ETL to manage data in Azure between subscriptions. And now let's move now to cross-cloud collaboration. We already have same thing in AWS. And due to nature of younger project and a much smaller developer team, there was not a big deal with the notebooks. There was a lot fewer notebooks than here. Now to enable the data sharing, we just need to enable delta sharing and create recipients. The instructions, it's real simple and straightforward. You create recipient, you get a key, you put the key into the other workspace. Now you have access and you see the data. So this comes to a little bit of a history how we managed this cross-cloud. Cross-cloud was just like the cross-subscription. S3 access directly was there. Because of age, there was VM with SFTP. Some time ago, we changed that to Azure Sync Agent. Azure Sync Agent is good. It specifies source and destination, and both are in sync. It does very good job. It totally takes care of ETL part. The only thing it doesn't have that you would want, based on the delta sharing, you lose complete visibility in access. So if I have data in AWS and it is important enough to control the access, and I can do that, all my IAM roles, all my logs are there. And then it goes to Azure magically through Azure Sync Agent and appears in Azure. But now there is no link to Azure IAM roles, Azure users, and what happens there. Same thing in Azure. I see this data, but where it come from, I have no clue. It came magically. So with Delta Share, that magic disappears, and now we can grant permissions and have access control to the remote delta shares, and that problem will be solved. And that was a big celebration in our team. So this is a screenshot from Azure Databricks UI, and delta shares received this is a AWS table that comes to Azure with no ETL, with no shared S3 access, and controlled with a code, infra as a code. So when we got access to this table here, we create Git commit. It's reviewed, it's monitored, logged. Okay, and coming back to the big picture, what has happened so far is by enabling Unity Catalog, we enable visibility across disjointed workspaces. Delta sharing removes ETL and shared access to blob stores. And on the upper branch, you see expanding scope of cross-subscription, cross-cloud, and then finally cross-company data sharing. The down branch is actually a lot more interesting. Lakehouse monitoring only works with Unity Catalog. Workflow migration. I'm not sure about others, but we do have other workflow tools that cost us quite a bit. And Databricks Workflow offer very attractive option if you are in Unity Catalog, because all the features you need, they are there, but only in Unity Catalog. Genie is many more, includes Genie and other AI tools. And well, that's our journey. Thank you. Questions?